All right, we are on 1.5, conditional statements. All right, a conditional statement is a statement that can be written in if-then form. The hypothesis is the phrase that follows if. And the conclusion is the phrase that follows then. Okay, and we often see that written as PQ, so if P, then Q. All right, our first example, we want to write a statement as a conditional. So you can register to vote if you are at least 18 years old. We want to identify the hypothesis and the conclusion. So our hypothesis is the P. So our hypothesis is if you are at least 18 years old. So you are at least 18 years old. Zoom in. And then our conclusion, you can register to vote. So then to write our conditional statement, we're just going to set that up into conditional statement form. So if P, well, our P is you are at least 18 years old, so if then you can register to vote. All right, next we're going to look at example B. A square must have 4 congruent sides. Identify the hypothesis and conclusion. Okay, so our hypothesis is if our polygon is a square, so a polygon is a square, then it needs 4 congruent sides. So it has 4 congruent sides. Okay, so then our conditional is if a polygon is a square, then it has 4 congruent sides. Okay. All right, so looking at our try it. All right, first one, a triangle with all angles congruent is equilateral. Okay, so I can set it up by finding my P and my Q separately and then creating my conditional, or I can create my conditional all at once. I'm going to create my conditional all at once. Okay, so first I want to identify my hypothesis. My hypothesis is that I have a triangle. And that triangle has to have all angles that are congruent. So if a triangle has all congruent angles. So congruent angles. Then it is equilateral. Okay, my next one, Alberto can go to the movies if he washes the car. Okay, so my hypothesis is that the car has been washed. So if Alberto has washed the car, then he can go to the movies. All right, next we're going to look at finding truth values of a conditional. Okay, so here we have our truth table. So our truth table for our conditional that if P, then Q. So our hypothesis is P, conclusion is Q. So if both the hypothesis and the conclusion are true, then our conditional is true. If my hypothesis is true, but my conclusion is not true, then the entire statement is false. If my hypothesis is false, but my conclusion is true, then the conditional is true. And if both my hypothesis and my conclusion are false, then my conditional is true. Okay, so you can see here that the only time a conditional is going to be false is if my hypothesis is true, but my conclusion is false. So that's the only time that a conditional will be false. All right, so my second example here, we're using truth values to see if our conditional is true. Okay, so our first statement, if a number is even, then it is divisible by 2. All right, so we're trying to see if this is true or false. So first we're going to look at the hypothesis portion. So if the number is even, then our hypothesis is true. And then for our conclusion portion, so if the number is divisible by 2, then the conclusion is true. Okay, so if both of those are true, then the conditional is true. B, if a quadrilateral has 2 pairs of congruent angles, then it is a parallelogram. Okay, so our hypothesis that if a quadrilateral has 2 pairs of congruent angles, that's my P. Okay, so we're assuming that our quadrilateral has two congruent angles. In our conclusion, our Q is stating that our quadrilateral is a parallelogram. Okay, so can I prove either one of those false? Well, if I had a quadrilateral with two pairs of congruent angles, okay, so there I have two congruent pairs of angles, but this is not a parallelogram. To be a parallelogram, I need two sets of parallel sides, and I do not have that with this. So this would be a false conjecture, or a false conditional statement. Okay, or try it. We want to find the truth value of each of the conditionals. A, if a quadrilateral has right angle, then it is a rectangle. Okay, so on this one, they're only saying that it has one right angle. So if I can draw a quadrilateral with only one right angle that isn't a rectangle, I'd be able to prove it false. Okay, so here I've got a right angle. But I drew a quadrilateral that is not a rectangle, so this would be false. So my hypothesis is that I have a quadrilateral that has a right angle. My conclusion would be that it is a rectangle. Well, the conclusion is false. That is not a rectangle, so this conditional is false. Right. B, if X is a midpoint on AB, then X lies on AB. So our hypothesis is that X is a midpoint of AB. Our conclusion is that X lies on AB. Well, if I draw line segment A, B, and they're telling me that X is the midpoint, and it's in the very middle, that's creating two congruent sides. Our hypothesis is true, X is the midpoint, and our conclusion is true, X lies on AB. So this one would be true. We have truth value of true. All right, so we're going to look at some more types of conditional statements. All right, so our first one, a conditional has a hypothesis and a conclusion. So that's the if, then that we've been working with. Next, the converse reverses the hypothesis and the conclusion. So we're flipping them. So instead of being PQ, if P, then Q, we're flipping it, and now we have if Q, then P. All right, next is our negation. So the negation of a statement has opposite meaning of the original statement. So it is not P, no P. So negation, squiggly line P, or we would say it as no P. All right, next is our inverse. Okay, in our inverse, we get that by negating both the hypothesis and the conclusion. So not P and not Q. So if not P, then not Q. Last one is our contrapositive. So we get the contrapositive by negating and reversing both the hypothesis and the conclusion. So we're flipping them and we're making both of them the opposite. So we're negating it. So it's not Q, then not P. So not our conclusion, then not our hypothesis. All right, example 3, we want to write and determine the truth value of the converse of the conditional. If you play the trumpet, then you play a brass instrument. Okay, so our hypothesis is that you play the trumpet. And our conclusion is that you play a brass instrument. Well, we are creating the converse, which means that we are flipping Q and P. So if we're flipping Q and P, then we would have if you play a brass instrument, then you have to play the trumpet. Which is false. You can play another brass instrument that might not be the trumpet. Right, our try it. All right, if a polygon is a quadrilateral, then it has 4 sides. So if we're flipping this to create the converse, then it would be, the right pen here. If a polygon has 4 sides, then it is a quadrilateral. Which would be true. All right, next. If 2 angles are complementary, then their angle measures add to 90 degrees. So for this one, if 2 angle measures add to 90 degrees, then they are complementary. And that is a true statement. All right, next we're going to write and evaluate truth values of inverse and contrapositive. All right, so our statement is if 2 whole numbers are both even, then their sum is even. So our P is that if 2 whole numbers are both even, so 2 whole numbers are both even, our inverse inverse, our negation, is that two whole numbers are not even. Okay, so we negated that. Our conclusion is that their sum is even. So the sum of two whole numbers is even. Our negation is that the sum of two whole numbers is not even. Okay, so then to put it all together, to create our inverse, so we keep our hypothesis and conclusion in the same position, but we are negating them for our inverse. So if two whole numbers are not even, then the sum is not even. And then our contrapositive, we are going to flip the negations. So if the sum of two whole numbers is not even, then the numbers are not even. Now we'll look at our try it. All right, we need to write a converse, inverse, and contrapositive for each of these truth values. Okay, so converse. Converse, we are flipping our hypothesis and conclusion. So our converse would be that if if tomorrow is Monday, then today is a weekend day. All right, next is our inverse. Okay, the inverse, we are negating it, but we are not flipping it. So we keep the original structure, but we negate it. So if today is not a weekend day, then tomorrow is not Monday. And then finally, our contrapositive, where we negate and we flip. So if tomorrow is not Monday, then today is not a weekend day. All right, next we're going to look at biconditional statements. Okay, so a biconditional statement is a combination of a conditional which is the PQ, so hypothesis, then conclusion, and a combination of the converse. Okay. If P and Q are both true, then the biconditional is true. If P and Q are both opposite, then the biconditional is false. Okay, so our biconditional, you're going to see that as P with a double arrow line between it, and then Q, you would say that as P if and only if Q. All right, so our first example, a marine biologist writes the conditional, if a seahorse gives birth, then it is a male. Since it is true that among seahorses only the males can become pregnant and give birth, should the marine biologist state this as a biconditional in a paper she is writing? So our P is that a seahorse gives birth. And our conclusion is that a seahorse is male. Okay, so our conditional is that if a seahorse gives birth, then it is male. Okay, and that conditional is true. Okay, and this should say converse. Okay, so for our converse, we flip it. So if a seahorse is male, then it gives birth. Okay, which is false. Not every male seahorse is going to give birth. Okay, so if both the conditional and the converse don't have the same truth value, then the conditional is false. So So because the conditional and the converse don't have the same truth value, one is true, one is false, then the biconditional is false. All right, let's look at our try it. All right, we want to find the truth value to figure out if our biconditional is true. All right, so our statement, if two lines intersect at right angles, then they are perpendicular. Okay, so let's do our conditional. Actually, our conditional is just the original statement. So I'm not going to take the time to rewrite it. So our conditional is the original statement. So I'm just going to go ahead and do the converse, which is our hypothesis and conclusion flipped. So if two lines are perpendicular, then they intersect at right angles. Okay, well, both of those are true statements, so our biconditional is true. Okay, next we're going to look at example 6. What are two conditionals implied by the biconditional? So this time they're giving us the biconditional, and we need to figure out what the conditionals are. All right, so our biconditional is a triangle is equilateral if and only if it has three congruent sides. So our hypothesis is that a triangle is equilateral. And our hypothesis is that it has three congruent sides. All right, so our conditional is that a triangle is equilateral if it has three congruent sides. So if a So our inverse, we flip these. If a triangle has three congruent sides, then it is equilateral. Now let's do our try it. All right, so what are the two conditionals implied by the biconditional? The biconditional is that the product of two numbers is negative if and only if the numbers have opposite signs. All right, so our conditional, so P, then Q. So if the product of two numbers is negative, then the numbers have opposite signs. Right, then our converse, QP, we flip it, so if two numbers have opposite signs, then their products are negative.